Hi, this is Shyamala Gauri, Assistant Professor in CSE Department, Rohini College of Engineering and Technology. Subject code CCS 355 Neural Networks and Deep Learning. Unit 4 Deep Feed Forward Networks. The topic covered in this presentation is VZ dimension and neural nets. Introduction. The VZ dimension is a fundamental concept in statistical learning theory that helps to characterize the capacity or complexity of a machine learning model. It provides a way of understanding how complex or expressive a model is in terms of its ability to fit various kinds of data. The VZ dimension is closely related to a model's ability to generalize to new unseen data. In the context of neural networks, the VZ dimension provides a theoretical framework to analyze the network's ability to represent and learn different functions based on the number of parameters. Example, weights and biases in the network. The basic definition of VZ dimension. The VZ dimension of a model is defined as the largest number of points that can be shattered by the model. Shattering means the model can correctly classify all possible labelings of those points. Example of shattering: consider a simple classification problem where we have two classes, plus 1 and minus 1. If a model can perfectly classify any possible combinations of labels for a given set of points, we say that the model can shatter those points. Mathematical definition: the VZ dimension of a hypothesis class is the maximum number of points that can be shattered by any model in the hypothesis class. Intuition behind VZ dimension. Number one, capacity of the model. The VZ dimension provides a measure of the capacity or complexity of a model. A model with a higher VZ dimension has the ability to fit a wider variety of data sets. However, a model with too high a VZ dimension may lead to overfitting, as it can fit even noisy data very well. Number two, generalization and overfitting. The VZ dimension is connected to the generalization ability of a model. A high VZ dimension typically indicates that the model has high capacity, meaning it can fit the training data very closely. On the other hand, a low VZ dimension may indicate that the model is too simple to capture the underlying structure of the data. High VZ dimension, more expressive, risk of overfitting. Low VZ dimension, less expressive, risk of underfitting. Learning and sample complexity. The VZ dimension also provides insights into the number of training samples needed for effective learning. A model with a higher VZ dimension will require more data to learn effectively and avoid overfitting. VZ dimension of neural networks. The VZ dimension of neural networks can be challenging to compute directly, but it is an important theoretical tool to understand how the size of a neural network impacts its ability to learn and generalize. In neural networks, the VZ dimension depends on the factors such as the number of neurons in each layer, the number of layers in the network, the activation function used in the network, the total number of parameters in the network. VZ dimension and generalization in neural networks. The VZ dimension helps us to understand the trade-off between model capacity and generalization ability. If the VZ dimension is too high, the neural network has a large capacity to fit any training data, which could lead to overfitting. Overfitting occurs when the network memorizes the training data instead of learning the underlying patterns. If the VZ dimension is too low, the network lacks sufficient capacity to learn from the data and may underfit, failing to capture the underlying patterns in the data. A relationship between VZ dimension and practical training. While VZ dimension provides theoretical insight into the learning capacity of neural networks, practical training of neural networks typically involves optimization algorithms like stochastic gradient descent that adjust the weights during training, regularization techniques to manage overfitting, cross validation to assess how well the network generalizes to unseen data. Though the VZ dimension plays a theoretical role in understanding the model's complexity, the actual performance and generalization ability of a neural network depend on practical training procedures, and the quality of data. Thank you.